been a bit busy with other things and haven't made videos in a while, so perhaps we'll ease back into it with something maybe less complicated. I don't know. Found this thing in the scrap bin the other day. It's called a FlatPAC Vicor. It's a power supply, 100 to 120 or 200 to 240 volt AC input, and the output just comes off these terminals here, these 400 watts, 13.8 volts DC. I have no idea what the state of this thing is, but I did notice something quite interesting. Peering in there is a fuse, ceramic fuse, and across it someone has poked a bit of wire. So I'm wondering if maybe something burnt out in this, caused the fuse to blow, and then they've gone along and put a bit of wire across the fuse and then exploded whatever's in here real good. That's the usual thing that happens, isn't it? Vicor, made in USA. V, it's quite hard to read what the model is there. VI, I think, dash MFP dash EQ. It's got a trim input and remote sense inputs, so you can like null out voltage difference or voltage drop across the cables. Let's have a look inside this thing and maybe we'll see if it's worth trying to turn it on. Not really sure what comes off, and being a Vicor thing, presumably everything's sealed up into some module that's attached to the heatsink, so it might not be very easy to find out what's going on inside this thing. I don't know if... No, there's no screws hiding under feet, but there's some kind of cover thing. Oh, it looks like it undoes screws down there. I'm guessing this is a ham radio type thing, amateur radio, being 13.8 volts, 400 watts. So that's the sort of thing you'd use for running a transmitter of some sort. I don't think this has any power factor correction. Just looking at the layout there, that where the input comes in. Okay, a small cover came off. And some input filtering. Capacitors there. So some optocouplers, I think that's what they are, to an OK and bus OK, AC OK, bus OK. Don't really understand that well what they mean with that labeling about. Let's see, there's 100 to 120 and 200 to 240, and then it's got ST1 and 2 and L1, L2 slash neutral. I don't know, but I was wondering if you join those two together to make it go in 110 volt mode, perhaps, because that might be what creates the voltage doubler. Bit difficult to know. Not seeing much fire yet, or evidence of fire, but yes, here there's a bit of wire across a fuse. Oh, that wire's not poked in very well. So presumably that fuse is blown. Don't know what that says. It says 250 volts. Bus ABC 12. Does that mean 12 amps? Maybe. Now I think we've got to unscrew those post things there to get any further into this. And also those, I think it's a hex type screw down there. So I go at that. Yeah, there's been lots of work going on, so I haven't been able to make videos much recently because I've got to try and finish. Well, I was working on finishing some circuit board designs for a company. What is this? That one was too big and the other one was too small. Yeah, so after hours type contract work. That's too small, that's too big. There's nothing in between. I don't know. Anyway, what I saw over the other side was some kind of sockety things. But I don't think those go big enough. Everything's not working. Let's see what else I've got lying around. Socket driver thing doesn't fit. There's this one. Maybe that's got something that will fit in there. I guess it's going to be the same thing because the 2mm one is too loose and the 2.5mm one is too big. I guess it's an imperial type thing. Well, it's obviously an imperial. There you go, look, a 7/64. No, that's too big. Try this then. A 3/32. That's the guy. Or is it? I just feel like it munched over. Oh no, it's because that terminal's in the way. Okay, here we go. There, we got the screw out. Got a different microphone set up today. Trying a new system using the NVIDIA broadcast noise reduction thingy, noise removal thing, on a completely different microphone, completely different audio interface. Got this Shure, what do you call that thing, microphone adapter thing, and then a different Sony. This time it's an ECM88B, and that thing there's the power supply for it. It's not unidirectional like the other one, but with the noise reduction, it's good, I think. Alright, these posts off. Well, you can tell me if it's good or not. The microphone, that is, the sound quality, whether that's worth keeping or go back to the other one, the old one, because this guy is unidirectional. ECM66B. And these posts are a bit annoying to get out. Alright, those post things are unscrewn. And now that starts lifting. Ah, look, there's another thing there. Like a warranty void if removed thing that I didn't notice before. Well, I noticed it, but it just didn't look like there was anything under it because it was kind of pushed in. I think these are going all the way through the heatsink. Looks like it, and yeah, the thread's all kind of stripped out. Okay, so now that thing should come off, presumably. Ah, and that reveals more screws. Oh, look, it looks like there's two modules in parallel under this. Ah, and the sense and trimming only goes into one. You can see that there's posts there. See that where they come out of? And there's posts there for soldering on that trim and sense, but it's not wired to that module. Weird. Yeah, we've got some more of these to undo. Must be pretty efficient if this thing can do 400 watts with... Oh, that's right, I was going to get an exhibit to show another power supply that's larger and rated at a lower current. Okay, interesting, because that kind of felt like a plastic base, but it's nicely anodized alloy stuff. Oh, look at that. So that's that, I guess. It's two modules and an input rectifying goofy. That's very strange. It's got a layer of foam kind of stuff. Ugh. What's that? Got a lump of something under there. Look at that though. This is bumpy, so maybe it's exploded. Maybe we should try measuring the there's definitely something's bulged up in the middle there. Maybe it's exploded. So this is a 300 volt DC nominal, 250 watt, 13.8 volt, 200 watt output, little module thing. Just don't know about the bump on it. Whether that's indication of something exploding out of it, or is that just normal? Maybe that's where they topped off the goo, the potting. These really nice low profile caps. It's 200 volts, 680 mic. Kind of want to unsolder that, but also want to see if we can get it to go. It seems those big things there are test points. They don't seem to be going through like wires or Strange. Is that thing there, is that a comparator? A TLC372? Sounds kind of comparatory. And there's a CNY, I think it says 17. Two optocoupler doofies. There's an IL420, seems to be another optocoupler. See on here, it does say what's presumably gate? Gate out, gate in, gate out and in. I wonder if that means AC OK as the in and bus OK as the out, maybe? Maybe that's what those are for? They don't need some kind of O-ring circuit. There's two devices, like TO220 thingies here. One of them's bent over a long way. And one of them's attached to the heatsink, which seem to be MAC223. I'm not sure what that is. Seems to be a transistor of some sort. There's also a jumper setting in there. It says B and D. Just sort of wondering, maybe there's some of these that they wire the outputs in series, like the 24 volt version maybe? I wonder if that's glued onto the heatsink. Interesting thing. Okay, I've been having a little look at this thing to try and see what the deal is, and I was just measuring stuff on the circuit board to see what's going on, if anything, and I found there's no, so the two outer connections to each of these power modules is the input, and there's continuity between those two, as you'd expect because there's a trace going there, but there's no, those two, but nothing between those two. It turns out that there's fuses. That little thing there that looks like a capacitor is a fuse and it's rated at 3 amps. That one's fine. There's another one there which breaks that module off from the main DC bus. That one's open, so maybe this is the module that's blown up. But it's also, well, no, maybe the other one is as well, or maybe it won't turn on without the other one running, I don't know. So that one's okay. What I also discovered is there's some reefer capacitors, some dirty reefers in there. Two of them, a big crack down the side of it. So that might have let the smoke out, although that is to ground. But then depending on what kind of circuit protection was involved, that doesn't necessarily matter. And it could have leaked a bit of current and blown up the capacitors, although there's no dirt around them, so maybe they haven't. So it seems like at least this module is burnt out. Not sure about the other one. And I have found, by looking at the data sheet, found one for this power supply, that that is strap, and you join those together for running it on 110 volts mode, and it does what you would expect, which is joins the center of the capacitors through to what would be the neutral, the connection of that one, so that these form a voltage doubler with the rectifier. And as expected, this fuse is blown. So I think we should replace all the fuses and try it out. Might as well give it a go. Still not sure what those extra transistor things do. Didn't really look into it very hard. Thinking it might be some kind of lockout thing if there's a fault. Oh, it's probably an inrush limiting thing. You see there's this NTC kind of thing. Maybe it's a PTC. And maybe these bypass it once the bus voltage has reached a certain amount. That's a sensible sort of thing that could be doing. That there will be, see there's a couple of resistors there off of the positive DC bus side going over to here. So there's probably a little voltage measuring circuit there for AC OK. I don't know what's the difference between AC OK and bus OK. Doesn't really tell you. It just says on the timing diagram, after power up, AC OK or DC OK falls, and then a short time later AC OK falls, as in it starts conducting, the transistor in the output there gets turned on. But here we got bus OK and AC OK, so it's a bit kind of misleading. Okay, so just because that's an interesting 400 watt power supply. Here is that's a typical 350 watt if you have a fan blowing over it power supply. It's quite interesting to see how that differs. Although this one here does have an active input on it, so it's got a PFC here with the boost converter thing. So I guess it's not a fair comparison, but it's interesting that pretty much all this part here is supposedly included inside these little blocks. Some special magic in there. Probably all military specification and rugged and good until it blows up. It's definitely that fuse is open, and that one there is fine, and the main fuse here was blown. So I'm going to try to rig up some other kind of 3 amp fuse across that blown one, and we'll replace the main input fuse, wire it up, join a meter across the main DC bus there so we can see if that comes up, and something across the output, and we'll see if it does anything. And yeah, that'll be us. I'll just get the parts for this to get sorted out and hooked up. Alright, I found some bits. Let's wire this thing. I've got some fuses. I think that's 2 amps. And a 5 amp. I think the original one was 12, so that's probably good enough. Not really planning to run this thing under load. I just want to see what it does. Oh, that fuse clip's very... Oh, it's snapped off completely. Okay, well, that's not a good start, is it? Oops. Okay. Yeah, so we might need to solder that in to find... It's been so long since I did this stuff. This type of thing. Lost all my bits and pieces amongst all the junk. Okay, and then I'm going to solder this little fuse across that blown one. Seems like the easiest way to do it. Just, well, it's better than bridging it out because that could be dangerous. Wondering if I could just solder onto that test point type thing there. Probably. Yeah, look at that. And we just need a little bit of wire down to that one. Make sure things are framed properly. Need to find some kind of a blast shield so we can be safe while plugging this thing in. That track there, which goes to that pad there, across the other side of the fuse goes to there. Just confirm that with the meter just to make sure. Yep. Good. So we'll just solder that onto there. Oh no, kind of melted the glue on the end of the fuse. Anyway, there we go. Got continuity between those now, so that's good. Now we need, we just solder in that other fuse clip. We'll solder the fuse into the fuse clip since the side of it snapped off. Seems to be doing the business. Then we've got some wire or power cord. Maybe we need to solder some test points on and set up this strapping. We've got a nice power cord there. And we need to join those two ST terminals together. Using up the good quality wire here, that's not very good, is it? Should be saving this for nice things. Okay, so that will select voltage doubling mode. Perhaps we'll put this down up this way. I don't know, maybe I'll just go a long way away when we turn it on. That way you can see what's going on and I will be out of the way of danger. In that case I might need different type of extension cord things set up. I bought in this thing here. Well, it's got a switch over here, but the cord doesn't reach. It's on a power strip with a switch. It doesn't reach, so there you go. So we'll switch that on and we'll see what happens once it's plugged in to here. Won't plug that in yet though. So we still need to set up some monitoring. I want to check the output voltage, so we can use the meter for that. That's easy, but I need another meter of some sort to measure this DC bus, see if that comes up. And I'll have to go and find some equipment for that because things are hiding and difficult to get at the moment. So I'll just go and grab another meter and we'll get that hooked up. Alright, we've got some stuff hooked up here. There's this exciting meter, which is quite a rare and interesting meter. DC volts there. I suppose we can put it on range, because we know it's going to be around 300 volts, so we'll be on the 1000 volt range. Probably put the resolution down so that it's going fast, I guess. You'll be able to see what's going on. So that's got these red and black wires. It's connected across the DC bus capacitance, the full thing. Then we've got this blue and yellow wires there. Got the fuse, I've done that. So we've got that there on the output of the power supply, that meter. Then I found another extension cord thing, and so now I can remotely turn this on and we can see what it does. I might just first test this meter here, since I haven't used that for quite a long time, and it's good to test this stuff before we commit to something. Look at this thing, it's a USB-C chargeable battery, which is possibly dead. No idea. Let's see. Oh, that type of USB cable is not going to work. You need, I think, one that comes from a USB-A port. There you go, it's lit up red. Yes, look at that, 9 volts. Okay, so that meter does definitely work. It is useful to know. We use it for something important. And we'll just test the other one, because why not? Yes, that reads. Time to do it. We'll turn on this power supply and see if any of the smoke escapes. I'll just be over here. Well, there you go. The input works, but nothing comes out the output. Kind of did a little bit for a little while. About 3 watts load. Did that fuse clear? We have to wait for this to discharge before we can touch it. Should have set up a discharging device. So presumably, well, we don't know, do we? We didn't really check properly if there was an enable on those modules. Further investigation needed. I just want to try it again once the voltage goes all the way down. Try it again, because it did look like there was a little bit of an output there, but not very much. Do you think that's low enough? Alright, let's try it one more time. Definitely nothing happened on the output. Alright, fine. Guess the last thing to check then, just unplug that and leave it alone for a while. The last thing to check is there an enable on those little power supply modules? It says gate in and out. I guess what we've got to do now is look up that thing, VIBGPCU, and see if there's terminals can prevent it from operating. No, what this is it B6P or BGP? Probably 6. VI beeping. Oh, it's because the battery's going flat. Okay, and we'll save the battery of that meter then. VIB6P-CU. Let's look at the datasheet of these modules to see what it says. Gate in, gate out. It doesn't actually tell you what that gate in and out thing. It gives you some specifications of the voltage levels. gate in, use open collector, 6 volts typically when it's open, and the low threshold is 0.65 volts. So presumably that gate in wires from a gate out of another one, and so you can control or link them together. So probably it's been locked out. And we could have a look whether these things are connected together or not. So the gate out going to the gate in of this one. Is the gate thing of the other thing going to that one? It looks like it. Okay, is that fuse blown yet? Nope, that's good. Okay, so that gate out is connected to that in. So it means this one here is the first one that gets controlled from something, and then that out is probably not connected to anything. Gate in. So we probably need to monitor what that point there is doing when it gets powered up. Presumably that's relative to minus DC bus. So that terminal there. And should we just yoink it low with something and see what it does? Seems like a good idea, doesn't it? I have to take a close look at this to see where that track comes from. Yeah, I've metered around a little bit. It's a bit of a roundabout thing. I have to start tracing it out to do much better than that. But it seems like that little jumper we're looking at decides which one of the gate out signals gets used for something. And the gate in signal there that we were looking at goes over to there, goes through a diode, and it splits to 2 ways, one related to that jumper and the other one over to here where it goes to that what looks like a comparator circuit, which seems to be referenced to the minus DC. So what I'm going to do is join that gate into the minus DC just before the diode, so we're on the diode blocked side of the circuit, so it doesn't really matter what we do on that side, because from the other side it can only pull down. So there you go, it's pulling down now by a bit of wire through the minus DC connection. And we'll give this one last go and we'll see what happens, just for fun. Let's get all this stuff back in position. Let's see if we can blow the fuse this time. Still got 170 millivolts on the DC bus. See if we can get a nice big. Let's see if we can get a nice big bang out of this thing, just to sort of prove a point. Anyway, it's ready to go. Everything's lined up nicely. Everything's hooked up properly. The battery's running out on the meter. That's okay. This one's hooked up. Leave that fuse visible so that we can see it blowing if necessary. Got this plugged in, ready to go. The extension cord's over there, ready to plug in to the other end of this. And we'll see what it does. Does nothing. Alright. Well, there you go. Either I've misinterpreted something and screwed something up with the enabling, or that thing is blown as was probably suggested by the fuses being blown, and yeah. Anyway, hopefully that is an interesting look inside a power supply. Well, not that far inside a power supply, but at least to see it's made out of fully potted modules that we can't really easily find out what's inside of, that we can't easily find out what is inside them. It'll be some kind of, probably a ceramic substrate with a whole bunch of things soldered onto it, and then probably some dies wire bonded onto it that are down on the aluminium base in there, and then the whole thing's filled with thick stuff that makes it all hard to get into. But wait, there's a bit more. After I'd put everything away and gone to bed later on, I realized something. The gate in connection on these power supply thingies is probably meant to be left floating to enable it and then pulled down to disable it. So why don't we try that? think what we should do is cut the track going to the that gate in terminal, and then try it out again and see what happens. See if it springs into life. Because on the first time we tried it, there was a very small bit of activity on the output. I noticed. Oops, be careful when cutting tracks. And let's see what happens. That's definitely not connected now. And so I'll wire up all the stuff again with the clip leads and the thingies, and then see what happens. Okay, I think we're ready to try this out. We've got the small, got the multimeter there on the output. We got this other bench type multimeter on the DC bus. Got a power meter on the input so we can see what's going on. Everything's wired up. That trace is cut over there, so in theory now those power supplies can't be disabled. And I'm going to stand over here and turn it on and see what happens. Now. Nothing happened. Alright, so that was a bit of a waste of time. I did check before that fuse there was still intact. There you go. So I guess the enable, we've tested it in both states now. Try it one more time for good luck. Ruined, or something else is up with it. It's definitely got volts applied to the input, and we've tried pulling high and low. Well, it's supposed to float high when the gate in is not connected. So I'm not sure what else I can do at this point. Anyway, thanks for watching. We'll finish off again, and unless I think of another thing before the video gets released. Otherwise we're going to move on to VCRs maybe, or some other thing next time. So stay tuned for that.